Hello again. In this video, we will then deploy our application. We have we have made some image processing. We use TensorFlow, no, PyTorch to do semantic segmentation. Now we can generate the image as we want it, and now we were going to put it on the cloud so that we can access it through an external API. So let's see how it's done. The first thing we will need to come here to the identity and access management. You can hit IAM here in AWS, and then you're going to create a new user. You could use your root user. I have already created a user here, add users, and then for that user you need to add some permissions. You probably don't need all of those. I was adding them for some testings I was doing. And then you have to create an access key. Here you create an access key. This one ends with S767. And that access key will be used by the command line interface. So here I have an empty folder. This is the empty folder. And then you are going to need the command line interface. You have to install the command line interface. I'm using the 2.13 version. You're going to need the serverless, and you're going to need Docker. So I'm using these versions of the programs. Make sure you install all three of them. For Docker, I'm using Linux here, but if you're using Windows, you can install Linux subsystem or iOS. It should work in any. You can always use Linux on top of those. You can Google for these packages. For Docker, I had to add my user to a group. If you Google it, you'll find it easily. And then then you have to configure your AWS. I have already done that. You remember my access key. You have to put it here, and then you will have a secret key. Put your region. I'm using East 2 region, not using Brazil because everything is more expensive here in Brazil. And then that's it. And then you can create your serverless application. So luckily for us, there are these templates that AWS makes available for us. And then on number 16 down here, we have already a machine learning template that is almost what we are going to do. I'm choosing Python 3.9 that I'm using now, and we already have a PyTorch machine learning example that already generates an API for us. We can do that manually. Oh, that's okay. That's okay. Sag. Now, I forgot to tell you. For deploying a lambda function, you can use something called lambda layers, or you can deploy them as a zip packages. But we are limited to 250 megabytes of the package already unzipped. And as this project has dependencies on openCV and pytorch and some large libraries, the model itself is more than 100 megabytes. Then we cannot deploy these functions with a lambda layer or with a zip package. So we have to use a Docker package, which is a middle term between the small lambda package and a full EC2 instance. So we deploy them with a Docker that is a self-container. We can think of Docker like a Python environment. I had some technical issue. Let's go back. So here we have the template was created for some files. This README you definitely should take a look, has some valuable information. Then the configuration files. Here we have an event that we can use to test our application, and the application itself, a Docker file, a model, and requirements. I'm gonna delete this model and then use the model that we saved. I have just slightly different name here, but it's the same model. And then the background image, I'm going to copy it to here to the application, and then let's take a look in this files. Let's start. We can start with the Docker file. So it downloads. Okay, this is the AWS install requirements. Copy the application. Let's copy also our image file, and our model name is now pytorch model. Okay, so the Docker file will run this. Here in the requirements we have to add openCV, so openCV Python. Make sure to use the headless version, otherwise the graphics library will give you some dependencies on graphic libraries will give you a headache. Requirements, the files, this seems okay. The application, okay, so this is a default application. It's used to make some predictions. I have the code. So basically I copied the three functions from the previous videos here. So get mask contour, and place figure in Podium. The same figures, the same functions. The pre-processing, I added it to tensor here inside. The categories, I could use a constant 7 here. Here here I used image open from Python image library, but we could use openCV decode. Here I'm encoding with openCV em encode. Here I could use em decode, but just to show you that we don't need openCV to decode binary images. So what it does, we will get the request as an ASCII image. So the request, we can, let me see where I have this. We can convert to and from base 64. If you just Google it, image to base 64, you will get several online encoders and decoders. So you can upload an image and it will transform it to an ASCII string. This is a binary string encoded as base 64. You can just copy it here and do the same. You can take an ASCII image and decode it to an image. I just done that for testing. So we will get this string, then we convert it and we open it as an image, and then I'm just printing the shape of the image to see that we are decoding it all right. Then I call the three functions. I'm rescaling the image so the string is not too big. If you use a big image, these strings can get very big and it can be annoying. So as the mobile phone image screen is not so big, so I can rescale it to 30% of its size. We can change it later or remove it. And then I'm replying the encoded string, return it in the return string. So we get a request string, and that is encoded in this event body will have the request string as a JSON, and we will return a JSON string where in the body we'll have status code, and in the body we'll have the encoded output. The code is straightforward. It's basically the same thing we did before. I added a flag here that we can use to save stuff to an S3 bucket if we wanted, or you're curious to see how you could save stuff to an S3 bucket. You can just put the object, pass in the bucket name, and you can save. Of course, you have to add the boto3 in the requirements, and it should be good to go. So config template, I think this is okay. And here AWS tells us that we have 10 gigabytes, but I got an error if I try memory sizes below 3 gigabytes. I think they are changing it, but it's a region-based configuration, so let's keep our application size in 3 gigs. Package type, and then we will create an access pointing not classified digit. This is the example, so we'll post a method, post a request to, I don't know, car segmentation will be our service. That's fine. That's okay. Save this. Continue some build, and there you go. So here we can use the event to test our application. So what we do is the following. We copy here the image, the converted base64 string of our image, and I have already done that in the event, in the JSON event. We copy here the string. So this is the JSON event that was created. So we copy there. Carseg, yes, and we can run the command, and it will test locally if our function is working. So it sends the event to our function, and then we can see that okay, openCV was installed and loaded, the image, the background, and the image could be decoded. And here we have the output string. If we copy this, we can actually, and we can see the image that was generated. So in this way we can test locally if our function is working. So finally, deploy. We can deploy our application. We cannot use underlines. No. Role creation. Yes. Okay. I can pause now the video. It takes some time. It will try to build the stack in AWS, the API access point and the lambda function and the connection between them. So this should take some time. It's uploading stuff. And you can see here in CloudFormation that today is 2nd of August. So okay, it is creating some stuff and it will take some time to complete. I'll be back in a few. Hello then. The upload is complete. I have a small issue because the openCV was not finding my file. I wasn't able to open the file, the background file, so I had to encode it as a string. It's strange because when I did it previously, I was able to copy here as we copy the model, but I think it's something to do with the problem that I made a second deployment. Maybe there is but okay, but now it seems to be working. So you can see in CloudFormation everything was uploaded. You can see in the lambda functions there was this carseg lambda function, and we cannot check the code because it's bundled in the image, in the Docker image, but we can test it. So here I can copy the same event I used to test my application, and we can send this event to our function. And if there is some error, it will show here. So it's generating some outputs. It seems okay. I open Postman, then to make before Postman we have to, it's not open, check our API. In our API gateway, the example already created an API gateway for us here in carseg. We can see there is this post method, and I had to deploy it, so to make it working and receiving external requests. So when I deployed it, then here in production stage or whatever, I get the link here I have the invoke URL. I can use this URL then here with Postman. I copy it here. I use carseg. The service I'm using here is only defined for post method, so we have here just post method. So I send a post request. I can drag and drop an image file here. If I select binary, it will automatically encode as base64 for us. We send the request. Now I'm using internet, sending the request from my home. Postman is a program, and then I can receive here a response, and that response we can then convert to an image to see the actual output. Yeah, it seems to be working. The colors, we have to convert the colors, so yeah, is it open? Yeah, it's here. In the image output, resize, or I can convert it here. Blend CV2. Now this should do the trick, and the image now should have the colors. I will pause the video and recompile. So we have to save this, recompile, re-upload, and then check if it's okay. I will do that and I come back to you. Okay then, I did build and upload. It took a small while. I sent this second image here. Now this the blue Subaru that we used in the other video, and now it looks okay. So we have a working API now that receives the images and generates this compiled image that we see here. So the final video, we will use MIT App Inventor. It's a small web app just to test and to show the results. Stay tuned for the next one. This one ends here. Thank you for watching. See you in next video.